Okay, in this video, we're going to continue talking about confidence interval. The subtitle is Reshaping to Get Probability. So I'm very happy to that I can say that we know all about the distribution of X bar. We know it follows normal distribution. When n is large enough, the number of sample size is large enough. And we also studied that the mean of the distribution is mu, which is the mean of the population distribution, and standard deviation, which is standard error here, this. So we know all about the information about this distribution. So we can guess here, this distribution is about X bar distribution. So we can guess if we pick so many samples and calculate the sample mean all the time, there will, because there will be like most of the time there will be variation. So I mean the samples wouldn't be same to each other. So we will probably always get, like most of the time, get different sample mean, and we collect those different sample mean. I will call X bar 1, X bar 2, X bar 3 as the number of sample we get. Let's say K. It's a K number of sample mean, and we see the distribution of it, and we will get this, right? So in this distribution, we can say X bars lives in this distribution like this. So this is where X bars live. Actually, this is not correct, like indication, but it helps to understand it better. So I mean, like drawing X bars here inside like this. This is like, I just want to emphasize this is the space that they live in. So what we want to do is investigate the probability of this distribution. So let's say there's like some value minus a and a. Let's say it's just like this, which means the mean of the population would be 0, by the way. It's just an example. So we want to calculate the probability of this area, which means if I say it's like 75%, it means that when we pick, there's population distribution, and when we pick one sample randomly, and we like most of the time we're not afford to get these kind of like many distribution. It's just imaginary distribution, and we already talked about it. So most of the time we only can get one sample, and it's pretty normal. And if we know that in these two area, it means 75% of X bar locates in this range, we can guess, oh, this, we get this sample and we got sample mean here, and we know that this it has 75% of X bars located in this area. We may guess, even though we don't know which, like whether it actually locates here or locates here, we don't know, but we can just guess that, oh, maybe it will locate in that area for 75%. I mean, probability. It's just belief. We don't know actually. We picked the sample, like really rare sample data. So maybe our sample mean locates here, which is out of this range. We don't know that, but by like empirical experience, we can just like guess, oh, probably 75 probability percent, this our sample mean will locate in this range. So that is the idea. So this is the idea. So but we can't investigate all of the range in all of the different distribution. So what we use for this is standard normal distribution, which has mean of 0 and standard deviation 1, and statistics, like scholars already found out the probability of each range in this distribution. So this distribution is all studied already. So we have the like papers for least number of probability that they already calculated by the range. So we want to use this, which is standard normal distribution, to get the range and probability. So we will change this distribution into standard normal distribution by scaling, and we get the range and probability in those range and take it back to our distribution. So let's take a look from the next video.